Hello friends. Today we'll cover the last of the object-oriented programming principles, polymorphism. Extending the concepts of inheritance and abstraction, we can write classes that represent a more abstract concept, a collection of more specific classes that are related. Let's use animals as an example by creating a script named animal that extends node, but we don't need to attach this script to any nodes in the scene tree. Here we can give the script a class name, then define properties and behaviors that are common to all animals, like a variable to hold the plural of the animal as a string, and another for the name for a grouping of this animal. And let's also define a function for the animal to move, eat, or speak. While we can easily define the plural of animal as animals, there is no word for a group of animals. We also can't define how an animal moves or eats without knowing what kind of animal it is, so the bodies of these functions can remain blank. But we might consider some behaviors to be common enough that they should have a default, such as speaking. While there are many different mammals that make a wide variety of noises, the majority of animals don't, including fish and insects. Most people would not describe them as speaking. So when telling any random animal to speak, we might consider the default behavior to be silence. So let's add some different animals to our scene tree, starting with a cat. We can now use inheritance like we have before to make any number of different animal scripts that inherit from animal, like cat. We'll then override the ready function to give the variables which are inherited from animal a value that is appropriate for a cat. The plural would be cats, and a group of cats is called a clouder. The behavior functions can also be overridden to change the silent speaking behavior to meow. Cats walk on four legs to move around, and I'll say that they eat fish. The actual contents of these variables and functions are not relevant, but the focus is on how they are inherited from the abstract concept of an animal to a more specific instance of a cat. We can repeat this process to make many more different kinds of animals to add to our scene tree, like a bird or a fish. And giving each a new script inheriting from animal, they can each provide their own unique values for the variables and implementations of the functions they inherited. The plural of bird is birds. A group of birds is called a flock. They fly to move around, they eat worms, and they chirp to speak. I'll get a head start on my fish script by copying the contents of the cat script. The plural of fish is fish. A group of fish is called a school. They swim to move around. They eat algae, but they don't speak. So by omitting the speak function, fish will use the inherited definition from the animal script for speaking. So far, all we've done is use the object-oriented principles we already know to inherit, abstract, and encapsulate the properties and behaviors of animals. But all of this allows us to use polymorphism by treating all animals as if they are equal and interchangeable. First, let's add a script to the root node of our scene and call it zoo, inheriting from node. Our zoo is full of different animals, but it doesn't matter what those animals actually are. Overriding the definition of the ready function for our zoo, we can easily iterate through our list of animals and treat all of them as if they are just animals. A quick and easy way to store all of our animals into a single variable, let's call it animals, is to use a function of node called getChildren. This returns an array of nodes, all of the child nodes of this node conveniently organized into an array in the same order as the scene tree. Because this relies on the children, we must use the tag @onReady. Since we know that all animals have the same properties and behaviors, We can iterate through each animal in our array of animals, and tell each one of them to speak. And despite treating them all as animals, each will speak in their own unique way as defined by their own particular scripts, or use the definition inherited from animal if they don't have their own. We can create as many levels of inheritance as we want to. So let's create another abstract script for mammals inheriting from animal. Mammals are a subcategory of animals, including all animals which have mammary glands and use them to nurse their young. These are unique properties and behaviors of mammals that do not apply to other animals. So we can add a new variable to the mammal script for the number of mammary glands this animal has, and write a new function called nurse. Again, the contents of the functions are not relevant to this lesson. This script will also need a class name in order to be inherited. Switching over to the cat script, since cats are mammals, and so we can give the number of mammary glands a value for cats, which should be 8. And we can add new mammals to our zoo as well, like a monkey. Monkeys are also mammals, but they only have 2 mammary glands. I'll once again copy the contents of another script to make things faster. The plural of monkey is monkeys. A group of monkeys is called a troop. They move by climbing trees. They eat bananas. And I'll say that they say ooh ooh ah ah. Our zoo script can now take advantage of this new inheritance structure to apply unique conditions specifically for animals that are mammals. We can directly use class names in conditional statements to say, if the current animal is a mammal, then we will execute some extra code exclusively for mammals. I'll just print out some extra lines describing our mammals. And we can see our output is both consistent for all animals, but also has something unique specifically for the 2 mammals. You can imagine how we could change our list of animals in our zoo to be any different kinds of animals, and we could alter our structure of inheritance to categorize them as precisely as we need to. In the next lesson, we'll learn about another data collection we can use to group related information. I'll see you in the next lesson.